Okay, we're going to talk a little bit about projectile motion. So we're still using our equations of motion though. So if we look at this example, the ball is rolling off of a tabletop 1.25 meters above the floor. So if we have our table, there's our ball rolling off. It is going to go some horizontal distance before it falls to the floor level. The problem really has two parts. How long does it take to hit the floor, and how far does it travel horizontally? This is a horizontal velocity as it's rolling off the table. The vertical component, how long does it take to hit the floor, can be treated as a one-dimensional free fall problem because the horizontal velocity doesn't affect the vertical free fall rate. So for A, we're just going to use the distance is equal to 1/2 gt squared. And we want to solve for t. So t squared equals 2d divided by g. So t is equal to the square root of 2d divided by g. We're going to plug in, so square root 2, distance 1.25 meters, divided by our g, which was, again, 10 meters per second squared. Running that through our calculator will give us the time it took to fall, and that's the information we're going to need to solve the second part. So it's going to take 1/2 a second to fall that far. Okay, so then if we look at part B, we want to know how far it travels horizontally. That's just a constant velocity problem because if we assume no air resistance or anything like that, it's going to travel at a constant velocity of 3 meters per second. So the distance horizontally is just the velocity times the time. So that's going to be 3 meters per second times 1/2 a second. The seconds are going to cancel, and we're going to be left with 1.5 meters are going to be traveled in that amount of time. But again, you treat it as two separate problems, a horizontal component and a vertical component. Okay, now in this particular case, we're looking at more of a straight projectile where we're shooting a bullet and it's flying to a target. So we're given a little bit different information. We've given the distance away from the target and the speed, which is going to alter how we work the projectile problem. So the how long does it take to reach the target, since it's traveling horizontally, is just going to be a constant velocity problem. So the distance is equal to the velocity times the time, or since we want to know time, time is going to be equal to distance divided by velocity. So we got 250 meters traveling 500 meters per second. It's going to give you 1/2 a second again. And then for B, how far does it fall? Now that we know the 1/2 a second, we can work that into the free fall part. Then we use this other equation. The distance is equal to 1/2 gt squared, except now we're solving for distance. So 1/2, 10 meters per second squared, and then 1/2 a second quantity squared. So 0.5 squared times 10 times 1/2 is going to give us 1.25 meters. So essentially the same answers as in the previous problem, except we're getting them the opposite way. So hope this has been useful discussion of projectile motion.